The following is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.
Hello, welcome back to Element 14 Presents. I'm David. Thank you for joining me for part 3 of my Halloween project, the capacitive horror. Today we're going to continue the build. We're going to be soldering up the main part of the PCB and connecting all the main components. So let's get to it. The first thing I really wanted to cover today was electrical safety. Now I'm going to be wiring this into mains and connecting it up to 230 volts in my home. Now I've got a lot of experience. I'm a qualified building services engineer with an electrical discipline and bias. Quite comfortable that I can do this without posing any danger to anybody now or in the future. Originally I intended to sort of build this project in an enclosure that I was going to 3D print, but after thinking about it for a while, that just didn't sit right with me, and I started thinking about all the times in industry when we've needed a box for something to go in, and you use an adaptable box. You're not unique. People have needed to do this in the past. So I actually went out and bought an adaptable box, which is pretty much what it sounds like. It's a plastic box, electrically rated. In this case, it's IP rated, and I bought a load of stuffing glands. For those of you who aren't familiar, they're the little plastic sort of gripping ones that have a rubber gasket that holds a cable in place. So this will offer me some strain release and some ingress protection or IP protection. The stuffing glands bring it up to IP44, but at least I know that when I put this together, everything's going to be electrically safe, cable tension restraint, and it's going to work for me. There are some other benefits to this. The adaptable box itself has got some really useful little runners that you can use to mount things in. So the first thing I thought I'd do is sort of think about a layout. Now what I'm trying to do is keep all the mains voltages to one side. So we'll start with my power supply over here, so we'll bring in the mains voltage here to power that, which means I want my relay board facing this way loosely. So again, mains voltage in this side, so all of the mains can be kept to this side of the board. From here, I've got the logic level outputs here and my 5 and 12 volt output on the power supply. So my Raspberry Pi can be mounted somewhere like that, and the holes line up quite nicely. And then at the top right, as I'm looking at it, sorry, I've got some space up here for the perf board, which I can cut down to suit, but will largely go here. That should be enough to get me started. So I think the first thing we're going to do is start butchering the box. The amplifier actually comes with a plug connection, which I haven't got the corresponding socket for, or the other way, socket plug. So I'm actually going to desolder it and put my mains cable straight onto it. This is the kind of thing that I would forget every time I do something. Because I'm making a permanent connection between here and here, and I've got a moulded plug on the end, got to make sure to run everything you need through the gland before you solder it. Sounds simple and obvious. I make a mistake virtually every time. Tighten up the stuffing gland just to hold it in place, make sure the strain is not on that cable, that soldered connection we've just made. So with the cable relief in and a couple of screws to hold the power supply in place, that's the first bit done. Next we'll fix the Raspberry Pi and the relay board in place, and then we'll get on to assembling the PCB. This is where everyone discovers my secret that actually I'm not particularly good at soldering. I can make it work, but I'm by no stretch the best in the world. I figure that practice makes perfect, and the more I do, the more I'll get better. I'll let you be the judge. We now have everything we need to get this project finished. All we need to do is stick it on the front door and see if we can scare some trick-or-treaters. Thank you very much for joining me today, but unfortunately that's all we have time for. Have you ever taken any projects from breadboard to completion? Have you ever used audio amplification in a project? Let us know at element14.com/presents. See you next time.